Very good evening, students. Is it audible to you? Hello, is it audible to you?
Yes, sir.
Okay. So today I start a new topic, that is multi-threaded programming. So before starting the topic multi-threaded programming, let me introduce the multitasking of operating system. Do you have any idea regarding multitasking? I don't think so, because because you don't have this paper operating system throughout this syllabi. So hopefully you don't have any idea regarding the multitasking. So what the multitasking with respect to operating system, if I try to explain it, let me give some example of real life that is happening in our machine, or rather in our computer system. What type of example I am talking about? Say when we are working in a machine, rather in laptop or desktop, we are doing different tasks at the same time. What type of task? Suppose we are listening some music, at the same time we are uh, using the painting software to paint something. At the same time we are using Microsoft Word to write something or to type something. At the same time we are using some PowerPoint, we are creating some PowerPoint presentation for our class, doing this 3, 4, 5 tasks. But thing is that all are these applications are nothing but the process. Your PowerPoint, your painting, your Microsoft Word, all your VLC player, all are nothing but a process. How can I explain a process? What is the definition of a process? A process is nothing but a program which is in execution mode. So these are all programs. We are just getting the output of those programs. When we are listening the music, it is basically the output of what? Output of VLC player. VLC player is nothing but an application. A program is written to develop for that application. So thing is that a process means what? A process means a program which is in execution mode. Fine. So all these are process. But if we think means in reality, now multiprocessor machine comes into the picture. But in earlier days, and still today also in some machine, we have one and only one processor. Try to understand. We are executing n number of processes at the same time. Listening music, writing some document in the Word file, using painting to draw something, using PowerPoint presentation application to prepare a PPT. So all these applications we are doing at the same time, but we have one and only one processor. Keep it in mind. So my next question naturally comes not from my side. All of you may ask this question, then how all this process, all these systems, painting, VLC player, PowerPoint presentation, Word, all these are working at the same time. So are they are not working at the same time? Is there any confusion? Answer is no. They're working with the same time. The process are running in parallel. But we have, keep it in mind, we have one and only one processor. Processor means who actually process where the program is executing. Where your program gets executed, that is the processor. In processor, the programs is executes. So that's why that is called processor. So you have one and only one processor, but you have n number of process. You are executing n number of process at the same time. Thing is that in reality, what happens? In reality, uh, the process, one single process, can execute in the processor at a particular time instance. I'm repeating once again. In reality, one single process can execute in processor in a single time instance. More than one process cannot execute at a single time instance. Then my question comes, how all these programs, all these process that we are talking about, how they gets executed, how we are getting this output. We can listen music, we can preparing our PPT, we can writing some words in the Microsoft Word document. So how this can be achieved if the processor is processing one single process at the single time instance? Is my question clear? Answer is, there is a concept of multitasking. What is called multitasking? The multitasking feature is your processor have a time slice. Your processor have a time slice like 5 millisecond or 4 millisecond. So first 4 millisecond will get process 1. Second 4 millisecond will get process 2. Say your process 1 is VLC media player. Your process 2 is say Word. Your process 3 is say PowerPoint. So first 5 millisecond is for process 1. Second 5 millisecond is for process 2. Third 5 millisecond is for process 3. So this type of switching is basically helps to execute all the process at the same time instance under a single processor. From our point of view, from user point of view, we think that all the process are executing simultaneously, or rather concurrently. Concurrently means simultaneously. We think, yes, at the same time we are executing PowerPoint presentation. At the running PowerPoint presentation, we are same time executing VLC media player. So I can listen music. But thing is that the processor you have only one. So without processor, program cannot execute. Process is, I just told you, na, process is nothing but a program which is in execution mode. Process means a program which is in execution mode. So without processor, your program cannot execute. So how you can achieve this concurrency, or rather how the simultaneous execution can occur? So this way, using this time slicing feature, using this multitasking feature, your processor give a room to each and every process. And thing is that the time slicing amount, that is 5 millisecond or 4 millisecond, it is so small, that human brain cannot differentiate it. That is the point. It is so small that the human brain cannot differentiate it. Human brain thinks that all the process, all the programs are running simultaneously, but in reality this is not happening. What happens in reality? Program 1, rather process 1 executes 5 millisecond, process 2 executes next 5 millisecond, process 3 execute next 5 milliseconds. Again process 1 comes back into the chain. When process 1 comes back into the chain, it resumes from where it left off. So in this way, processor gives the room, or rather gives the chances to every process, so that the multitasking can be achieved. So far, multi-threading has a similarity. Today's topic is multi-threading. Multi-threading has a similarity with the concept multitasking, but this is not, multi-threading is not same with the multi-threading. There is a difference. Multi-threading is not similar with the multitasking, better to say, because multi-threading is implemented for a single program, whereas multitasking is implemented in case of more than one process, rather multiple tasks. So these two things are not same, but the concept is bit similar. So now coming to the topic, what is thread? Then I'll come the topic multi-thread. So I'm trying to share a note with you. I will send the note to your mail. Let me share the screen with you. I have scanned it. So I think it is visible to you. Yes, na? So what is a thread? First of all, my question is, what is a thread? Then I will come to multi-thread. Definition, formal definition of thread is given over here. A thread is similar to a program that has, mute yourself. A thread is similar to a program that has a single flow of control. It has a beginning, a body, and an end, and executes commands sequentially. In fact, all main programs, so far we have written only one program, that is main, and the main program is called single threaded program. Fine. So what is thread? Thread is bit similar to the program that has a single flow of control. It has a beginning, has a body, and an end, and it executes the command sequentially. That is, the body, it is written inside a thread. In fact, all main programs can be called a single threaded program. You can think a thread as a module of a program. Do you know what is module? Module is a smaller part of a single program, which have a beginning, has a body, and definitely has an end. And it executes its instruction set sequentially as it is written inside that module or inside that thread. And every program have at least one thread. So far we have written only single threaded program because we have one main program, and that main is itself is a thread, and that's why you must have a single thread in your program. Till date, we don't have any idea regarding thread, so we don't know whether how many threads it is running in our program. Now today onwards we understood that yes, if we have written one main program, rather one main method, that is a single threaded program. Java has a feature which supports multi-threading. That means more than one thread can execute simultaneously, rather concurrently, just like multitasking. And Java supports it. Java is such a type of language which support multi-threading. That means point number 3. Java is such a language which support multi-threading. That means Java enables to use multiple flow of control in developing program. Each flow of control may be thought of as a separate tiny program, just I discussed, separate tiny program or module known as a thread that runs in parallel to others, that runs in concurrent manners. A diagram is given regarding this. Look, this is the main thread. Fine. Main thread is basically creating the other threads. Fine. So main thread, thread A, thread B, thread C. From main A, main thread, it gets created. Thread A, thread B, thread C. When thread A, thread B, thread C gets executed, they are executing in the manner like multitasking. Sometimes some milliseconds of time thread A executed, some millisecond of time thread B gets executed, some milliseconds of time thread C gets executed. Because we have only one processor. And without processor, your process cannot get executed. Process means program which is in execution mode. Try to understand. Process means a program which is in execution mode. So that means you need a switching between this thread. You need a switching. Switching means interleaving. Interleaving. Thread A interleave to thread B, thread B interleave to thread C again interleave to thread A. Fine. And this interleaving manner is not like in sequence. Matlab thread A, then thread B, then thread C. No. It may be thread A, thread C, thread B. It may be thread B to thread A. So it depends upon the processor because it takes in the random manner. So that's why I will show you today when I am executing a program of a thread, the output of the program may not be always same in your machine, or rather it may differentiate from your friend's machine, rather output from your friend's machine. What is the reason? The reason behind this is this: switching. Thread A, thread B, thread C. You have 3 threads. If you imagine it, if you consider it, then the switching between thread A, thread B, and thread C may not be a sequence. Thread A, then thread B, thread C. No. It may be thread A, then thread C, then thread B, then thread A again. In this way, the switching occurs. And when it will come back, just earlier I mentioned, again I am repeating that point, when it comes back to the thread A leaps from thread A, processor goes to thread B, fine. Thread B to thread C. When it comes back to thread A again, it resumes. It will not start from very beginning. Try to understand. If there is a 5 lines, 5 instructions in thread A, these are the instructions, the line says in the instructions. If this is when it is left from thread A, processor leaves from thread A. If it is line number 3, then when it resumes, it starts from line number 4. And I think, or rather we think, when these threads of this program gets executed, we think yes, all the threads are executing simultaneously, but no, at the single time instance, one single thread gets executed. Its concept is similar to the multitasking, but point is, this is not multitasking. Multitasking and multi-threading is not same. Concept is same, but there is a difference. I will discuss the difference in the following table. There is a table given in this notes. Look, what is written? Figure illustrates a Java program with 4 threads, 1 main thread and 3 other. The main thread is actually the main method module, which is designed to create and start the other 3 threads, namely A, B, and C. So without main, you cannot start it. And you have to create the thread. Today I will implement this threading concept in a program. So at that time, you will understand what is the meaning of this. So you have to create a thread and you have to start. So that's why you must require a main thread, and the main thread will start this other threads. But it is not the case. I will show you that matter. It is not the case, as because main thread initiate or rather create the other three threads, or initiates or rather starts the threads. It doesn't mean all three threads was completed, then main thread gets stopped. No, main thread may stops before stopping other three threads, before completing other three threads. It may be the case. I will show you the output. Once initiated the main thread, next point, once initiated by the main thread, the thread ABC runs concurrently and share the resource jointly. Try to understand the meaning, share the resource jointly. What is the meaning of this? Shared resource. Can you understand what is the meaning of shared resource? Like a file. A file is there, notepad. File means consider a notepad. A notepad is there, thread, something is written over there. Say your name is written over there. Thread A is reading the name from that file. Thread B is writing your phone number in that file. Thread C writing your mail ID in that file. So that file is a shared resource with the respect of these three threads. Try to understand the meaning. So that is the point. Thread can be a shared resource. Thread can be used. Multiple thread can use a shared resource among themselves. But there must have a process, otherwise you will face some problem. I will discuss in detail this topic, that is shared resource of multiple threads, in detail later on. Because when we are accessing shared resource from multiple threads, there may be some real life problem. I will discuss this later on. And the ability of a language to support multi-threads is referred to as concurrency, that I earlier mentioned. So this is the brief introduction of what is thread, what is multi-thread, and what is multitasking. Threads running in last point, thread running in parallel doesn't mean that they actually run at the same time. Already discussed. Since all the threads are running on a single processor, the flow of execution is shared between the threads. The Java interpreters handle the switching of the control between threads in such a manner or such a way that is appear running concurrently. But actually they are not running simultaneously. Once upon a time, one particular time instance, a single thread is executing. But time instance is so small, the switching operation is doing so fast that our human brain, human eye cannot predict that this are there a switching operation occurs between these threads. That's why we it seems that all the threads are running concurrently. Actually, in reality, this is not happening. So the next part that I'm going to discuss is the difference between the multi-threading and multitasking. Earlier I mentioned the concept is same, but these two are not basically the same thing. Multi-threading and multitasking is a different thing, because, and check what is the difference. It is a programming concept in which a program or a process is divided into two or more subprograms or threads that are executed at the same time in parallel. So this is multi-threading. It's a programming concept in which a program or a process is divided into two or more subprograms or threads that are executed at the same time in parallel. What is multitasking? It is the operating system concept in which multiple tasks are performed simultaneously. I already discussed with you. I started my discussion with the concept of multitasking. Then I entering into the topic multi-threading. So I hope this difference is very clear to you. Second point, it supports execution multiple parts of single program simultaneously. On the other hand, for multitasking, it supports execution of multiple programs simultaneously, because in case of multitasking, we are handling different process. And I earlier mentioned what is the definition of process. Program is in execution mode. You may note it down. What is the definition of process? A program is in execution mode. It's called process. So we are tackling the process in the concept of multitasking, whereas we are handling the multiple execution of multiple parts of a single program in multi-threading. Third point, the processor has to switch between different parts of thread of a program. Processor has to switch between different parts or threads of a program, and in case of multitasking, the processor has to switch different program slash process. Then it is highly efficient, less efficient in comparison to multi-threading. Why? Because it is in the under the same program, under the same process. So that's why it is more efficient than multitasking. Less efficient in comparison to multi-threading. Next point, a thread is the smallest unit in multi-threading. Thread is the smallest unit. We already discussed what is a thread. It is nothing but a module. And in case of program slash process, this is the smallest unit of multitasking environment. It is the entire program. Process means it's an entire program. So that is the smallest unit. Process or program. Program and process not the same thing. Program which is in execution mode is called process. So that's why it is written program slash process is the smallest unit in multitasking environment, whereas thread is the smallest unit in multi-threading environment. It helps developing efficient program. It helps developing efficient OS operating system. Last one, it is cost effective in case of context switching, expensive in case of context switching. Definitely, because it is in a single program, but it is in different program or different process. That's why it is cost effective in the case of context switching. In case of multi-threading, it is cost effective. Context switching is cost effective. And in case of multitasking, it is very expensive in terms of context switching. What is context switching? We already know. Context switching means thread A, thread B, thread C, again thread A. This is called switching, context switching. Fine. I hope this much is clear to you. What is the difference between thread and rather multi-thread and multitasking? Multi-threading and multitasking. This much is clear to you. Then entering into the topic, that is thread. How Java create a thread, how multi-threading is supported in Java. That thing needs to be discussed. There is a class, try to understand. First I am briefing this, then I will go through the notes. Java creates its thread, rather multi-threading when I am talking about. Java creates its thread by two means, by two ways. First approach is there is a class, defined class named thread. You can create a thread by extending thread class, or you must create a thread by implementing runnable interface. Note it down or keep it in mind that Java creates its thread by two approaches. Number one is extending thread class. Number two is implementing runnable interface. And under the thread class, there is a run method. Fine. When I am extending thread class, that means inheritance concept implemented. When I am extending thread class, the run method of the thread class needs to be override, and your thread body, the set of instructions that you consider as a thread, have to write under this run method. I will show you in a program. Today I will show you in a program. I will execute a program of multi-threading. Try to understand. First, theoretically try to understand. So I mentioned two approaches Java can use to create a thread. Number one is extends thread class. Thread class is already defined. And number two is implementing runnable interface. Second point I mentioned, under thread class there is a run method, and run method is nothing but the life of a thread. It is the heart of a thread. What is the meaning? Why I am calling it is the heart of a thread? Because the thread body, the set of instruction that we consider or that you consider to be a thread's body, it should be written inside this run method. Fine. So that's why what you have to do, you have to override the run method. There is a method public void run. You have to override that run method. I hope you understood what is the meaning of overridden method. Same signature, parent class as well as in child class, but the definitions of the methods is different. But the signatures means return type, name, as well as the parameter list. All three are same. So you need to override the run method. Fine. Then what you have to do? You have to create an object of that thread, and there is a start method. Start method is used to start that particular thread. So what are the steps I mentioned? I'm again repeating, then I will come back to the note. First point is we can create a thread by two means. Number one, extending thread class. Number two, using runnable or rather implementing runnable interface. How can we create a thread by implementing runnable interface? That I will discuss later on. First, think how to create a thread by extending thread class. So I have to create a class which extends the thread class. Under thread class, there is a method. It is public void run. You have to override that method public void run. Fine. And when you are overriding that method public void run, the set of code that you have to write under public void run is basically the heart of your thread. Heart of your thread means that is the particular code sequence that you want to execute in that particular thread. So that is the part you have to write. Then what to do? Then a class has been created. You have written your thread code inside run method. Fine. Next step is you have to create an object of that thread class, not thread class, that is extended class. Class A extends thread. So you have to create an object of class A. And on the class A object that you created, you have to call a start method. That is also coming from thread class. You have to call a start method to initiate that thread, to start that thread. Try to understand. So that's point written over here. Creating thread in Java is simple. Threads are implemented in the form of objects that contain a method called run. The run method is the heart and soul of any thread. It makes up entire body of a thread and is the only method in which the thread's behavior can be implemented. The run method should be invoked by an object of the concerned thread that I mentioned, and this can be achieved by creating the thread and initiating it with the help of another thread method start. So you have to call the start method to initiate that thread that you have called that you have written inside run method. So I'll show you in a program. So this page gets scanned twice. So I'm skipping this page. So that I already mentioned, a new thread can be created by two means of uh, by creating a thread class, or second point is implementing a runnable interface. First point is by creating a thread class, and second point is by converting a class to a thread, that I will show how to convert. Rather, second point is implementing runnable interface, implements runnable interface. That is the point. Fine. So if your question comes how many way you can create your thread, answer will be two. First answer, by extending thread class. Second answer, by implementing runnable interface. I will show you how you can use implement runnable interface. So I will entering this part. First approach, extending thread class. So I will show it in a program, and that's implementing run method. So extending thread class, your class needs to be extended from a thread class, and you have to override that public void run method that I just mentioned. You have to override public void run method. Fine. Then you have to create an object of this myThread class. What is the myThread? Look, myThread is what? MyThread is class myThread extends thread. So myThread is your class name. Fine. Under this class, you have written this public void run. This is your thread code, and this is the heart and soul of your thread. And then what to do? You have to create an object of that myThread class, if the class name is myThread, and you have to call the name of the object is a thread. Fine. MyThread a thread equal to new myThread. Then you have to call the start method to initiate that thread, or rather to start that thread. Fine. The thread now gets executed, rather starting its execution. So it is explained in this text. So next I will move to the program. First discuss the program, then I will discuss the life cycle of the thread. I hope the screen is visible to you. Programming screen. This is visible to you.
Yes, sir. Yes, sir.
So let me start to write the program. So I'm considering a class, my class. So it is A extends thread. So I'm applying the first approach, that is extending thread class. Fine. Class A extends thread. I have to override public void run. This is the method that is already defined under thread class, and I have to override this method. Fine. So I'm just overriding this method, and inside this method I print, say, just the value of I equal to 1 to I lesser equal to 5 I plus plus. System dot out dot println, say I equal to class of I, and after coming out from this loop I just printing uh, exit of thread A. System.out.println exit thread A. Next part, I'm just copying this part into another thread. Class B, I'm creating one more thread. Class B extends thread, public void run will be the method. Instead of I, I'm printing the value of j equal to 1 to 5, j equal to plus j. Fine. And this is system.out.println exit thread B. This is my thread B. Fine. Another thread I am going to create in the same manner. It is thread C. Extend state class, public void run. So it is k equal to 1 to k lesser equal to 5, k plus plus, k equal to k, the value of k gets printed, and this is the exit of thread C, exit statement of thread C. Fine. So this is the thread definition over. Next part, that is our main thread. So main class name, say I have to give the main class name test50 as the file name. I've given test50. Public static void main string args. So what I have to do, I mentioned earlier, what are the steps I have to follow? I have to create an object of this thread class. So new A, fine, because A is my first thread class. And after creating the object, I have to call the start method, start, yes, on it. New A dot start. Similarly, new B dot start. And similarly, new C dot start. So what I'm doing, I've just created the thread object for thread A, thread B, and thread C, and I'm calling the start method to run the thread, or rather to initiate the thread. And last line of this main method I've written, that is exit from main thread. This is my main thread. Try to remember the figure of the first page that I have already shown you. Main thread is basically initiating the three threads. Here are the three threads, A, B, C, and I'm starting the thread by calling the start method. And when the execution will be completed, then automatically it gets stops. Fine. In the next topic, I will learn the threads life cycle, where I will show you we can stop the thread, rather we can kill a thread before the completion of its task. Yes, that is possible also. So this is exit thread main. Fine. So this is the code for creating three threads and creating the object of the thread and calling start method to execute the thread. Is there any confusion? Fine. Let me compile it. No error. Look, check the output. How enter that switching operation performs. Look, exit thread main, that is the first line of the output. What it means? It means this thread gets started, this get thread started, this thread gets started. Thread A gets started, thread B gets started, thread C gets started. Fine. But thread A, B, C are not getting the processor. Main thread gets the processor and executes this line. First three line gets executed. That means all three started its execution. Started but left. Processor, these three threads are not getting processor. Main thread gets the processor and that's why this line gets executed. And it is main thread is just completed, ended before completion of other three threads. Though main thread initiates all these three, but it is not the rule that all three will be completed then main completed. No, that I earlier mentioned. This is the example. This is the output of the program that shows this. That is not the mandatory rule that main thread should be stopped after all three get stopped. No, it may be stopped at any point of time. So first exit main thread means main thread gets stopped. No more instructions in the main thread to execute. Fine. Then what happened? Thread A gets processor and it's completed its task. 1, 2, 3, 4, 5 and exit thread A. So thread A stopped. Now thread B, C remains. Look, then thread C get processor. Thread C get processor K1, K2, K3, K4, K5. Exit thread C. Fine. Then thread B gets processor. 1, 2, 3, 4, 5. Exits thread B. So this output may not be remain same with the another execution of the same program. Look, if I once again execute the program, the output sequence may get changed because when which thread will get the process, it not depends upon us. It depends upon the internal system of your computer. Again, I am executing the program, but I can get different output. Look, yes, different output comes. Exit treatment. Look, switching occurs between the threads. K equal to 1. So C thread gets executed. I equal to 1. Thread A. Then thread J means thread B. Then again thread A. Then thread C. Then thread A. Then thread B. Then thread A. Look, this is the switching operation performs. Then look, K equal to 2. Then I equal to K means thread 3. I means thread 1. J means thread 2. I means again thread 1. So switching operations performed. And exit from thread A, this line gets executed. So thread A stopped over here. Then K4, K5, exit thread C, thread get C gets stopped. And then thread B remains. J4, J5, exit thread B. If I execute once again, I will get different output. Look, look, this output is not same with the earlier one. Thread main, look, here thread A completed lastly and thread B prints all its statements. Only this statement left, exit thread B. This statement executed after completion of thread A. So this is the beauty of supporting multi-threading in Java. Multiple threads are executing simultaneously in a single processor. In a same program, we can create multiple threads and we can execute them simultaneously under a single processor. There is a switching operation performed between these threads, and that's why we are getting different output at different execution. That is the points to be highlighted in this topic. Another image which is explaining multi-threading. Look how the processor is. So why? Hello, hello, hello.
Hello.
Is this visible? The screen is visible to you. Is it audible to you? I cannot understand because I am not getting any response from your side.
Sir,
Sir, not visible.
Hello.
Not visible, sir.
Now I am. Now I am.
Not
no,
visible.
sir.
क्या रहा है आवाज?
Screen is not visible because I have
कट रहा है आवाज.
off the sharing.
Hello.
Hi.
Hello, sir.
Hello. I am. Your voice is audible to me. My voice is audible to you. Is my voice is audible to you?
Yes, sir.
Yes,
Now
sir.
it is
Yes.
audible.
Now
Okay.
is it audible?
Fine. 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 Let me share the screen once again.
Yes, sir.
Yes, sir.
Now it is audible.
Some technical issues are there. That's why I stopped my sharing screen.
Okay.
Is the screen visible to you?
Yes, sir. Now visible.
Fine. So what this diagram depicts, this is the multi-threading concept is depicts. Thing is that time slice considered over here is the 1 second. The first picture, that is basically a single thread concept. Means only one thread it is executing. Fine. When only one thread gets executed, that means sometimes it shows busy. Busy means the processor is engaged. Processor engaged means thread is executing in the processor. But sometimes it is showing that it is not busy. So naturally next question comes, why it is not busy? Why as because single thread is running, still processor is not busy. That means the thread is not executing over there. So what is the answer? The answer is at that time your thread may be taking some input from the user. When it is taking some input from the user or doing some other task, at that time it will not execute in the processor, and that means processor is the expensive resource to you. You are losing your expensive resource. You are just keeping idle your expensive resource. So that's why look, this is a 7 seconds timeline. Out of this 7 seconds, your processor is busy for 4 seconds. Try to understand. Your processor is busy for only 4 seconds, and rest 3 seconds is the waiting time. Your processor is not busy, so you are keeping your processor idle. Fine. So time executing code 57%. Out of 7, you are executing 4 seconds. So 4 by 7, that is 57%. And 3 by 7, that is 43%. That is your time waiting. Time waiting means you are basically keeping your processor idle 43% of time. This 7 seconds timeline, if you check, if you see. Whereas when you are using two-threaded or rather multi-threaded program, what happens when your processor is busy, P1 and P2, that is thread 1 and thread 2. When processor busy with P1, then P2 is not executing, fine. But when P1 leaves the processor due to some its personal work, leaves the processor, P2 automatically enters into the processor. So processor is not sitting idle. Processor always executing some process, right? That's why you are fully utilize. You can fully utilize the processor because processor is expensive resource. So that's why look, total time of executing code it is 8 seconds and total time of waiting it is 0 seconds. Because each and every second either process P1 or thread P1 and thread P2 or thread P2 is executing in the processor. So that's why no wastage of time, rather no wastage of processor is occurring here. So that's why total time executing 8 seconds and total time waiting 0 seconds. So that's why executing code, that is utilization of the processor, is 100% in the case. But in this case, the utilization of processor is only 57%. And your time waiting in this case is 0%, whereas in this case it becomes 43%. So which one is advantageous? Definitely multi-threading. Definitely we'll move to the concept of multi-threading because we can utilize our processor, which is a very expensive resource, for entire time, for throughout the execution time. Otherwise, in some point of time, if I go for single threaded program, at some point of time our processor is taking rest, which is not desired. So is this clear why we are going for the multi-threading program, multi-threading concept in the program? Is this clear? Fine. So I have just discussed about the program, rather implementations of this extending thread class, and the second part, that is run method. How can we start a new thread? This much we have discussed, and I already executed this type of program. Yes, executed this type of program in the just executed this type of program and show you the output. And it has also been checked that we are getting different set of output at different execution because it depends upon the processor, rather upon the thread when it gets the processor and it process. So that's why we are getting different set of output at different time. So today I am stopping here of this topic thread. Next class I will discuss the topic life cycle of thread, and I hope this much you have no doubt. That is the basic concept, basic fundamentals of thread, why we use multi-threading, and how we can implement this multi-threading concept in program. This much is clear to you, I hope. And next class we'll start the discussion with the life cycle of thread.